In this lesson, we will be talking about closures and completion blocks. Closures are a very powerful feature of Xcode and Swift, and we use a similar thing in Objective-C called a block. And what they do for us is closures are like a function without a name, and they help us in situations such as when you want to pass a function as an argument inside another function. They're being used in so many different places. Let's go ahead into Xcode, and I'm going to start a new project, macOS command line tool, and I'm going to call this one closures Swift, and let me maximize that. Perfect. Okay, so here, the first thing we're going to do is just to get a sense of how you declare a new closure. Imagine if you had a function called this is a function, doesn't take any arguments and doesn't have any return types. So this is the simplest way we could introduce a function. Here's a name, no arguments, no return types, and this is the body of our function. If I wanted to convert the same thing into a closure, I would go ahead and say variable, this is closure, and that closure would become something like this. You open the curly brackets first, then you talk about your arguments, and then you talk about whatever that's going to happen within that body. So let's see what it means. It essentially means I have a closure that takes in some arguments and returns something as long as something else is valid, or as long as the other thing that you want is being met. Now, this might seem a little bit complicated, so let's go ahead and actually write one that helps us doing something. I'm going to go ahead and say, well, I have a variable says say hi closure. All right, this is a variable that's going to say hi, and then I'm going to open curly brackets. I'm going to say my argument is imp name, which is of the type string. And then for that, I want you to return me another string in return. What would you like to be returned? I like to say hi, and then whatever variable I have entered. So theoretically, this is the function that has an input argument and has a string output and returns that. If I wanted to convert that function into here, if I wanted to say func, say hi function, that would be this. That would be imp name, just like what we have done many times. It returns a string, and then it does this, return that. So these two are essentially identical. Now, I don't want to use the function, I want to use the closure now. So in the closure, I'm going to say I have this, and the way I could use it, I could say, well, print, what do you want to print? Here is the value I want to print. This closure, so I'm going to get the closure, say hi closure for a value such as my name, because obviously it receives one argument. So if we run this now, it should say hi and the name that comes after it, in this case with one space. Let's see if that is the case. All right, so far we managed to have a closure that's the most basic closure that takes in an argument and does something. And we understood kind of the format of it is whenever you want to have a closure, you have this format. Curly brackets, arguments, returns in. Now let's go ahead and write another one. So in this new one, we're going to see some of the actual power of closures. I'm going to go ahead and actually I'm going to comment everything out in here so that they don't get mixed down there when I'm printing values. And here is a little bit of an explanation of what I'm trying to do. Let's say I have a function, and my function, you don't need to do this because I'm going to change it real soon. And my function is set my function, and it has an argument as an entry to it. Let's say that argument is numbers, all right, or values. So I'm going to say values, all right, and those values are an array of integers. And then I'm going to do something on this array of values, whatever that thing is. Maybe I want to find out which one of those are larger than 100. So larger than 100. And then I want to have another function that goes ahead and says, well, tell me the ones that are, and this one I'm going to call 1, the ones that are smaller than 100. And you can imagine this thing can continue forever. So many different functions. Each of them has a different, let's call it, condition. So here is the thing. I have so many functions that are very similar, but each time the condition changes. So what I'm trying to do is I'm trying to add the condition as one of the arguments in here, so I can only have one function that can do so many different things. And we can do that using closures. Let's see how I'm going to manage that. I'm going to say, give me a function. Let's call this one multi-purpose function, multi-per function, like a cat. And my multi-per function has these things. First of all, it has a set of values that we receive. So let's call it the vals, and the vals is going to be an array of integers. So that's the integer values that we want to do something on them. But what we want to do on them, I'm going to make it a closure. I'm going to say it's a closure, and that's just the name of a closure, name of an argument. You can call it whatever you like. Makes sense to call it closure here. I'm going to say it's a closure that receives an integer and returns a boolean. So let's see what that means. It means you will have a set of values and you will have another function as an entry for this function. I'm going to rewrite this once we are done as if it were two separate functions, and you would see how it works. But for now, I'm going to go ahead and say, well, here is what I want to do. I want to say for each number in vals, this is what you want to do. You want to say if closure of that number, each number, if that was a valid value, I don't know, just print it for now. Say print each num. That's all you're gonna do for me right now. And I could change the print to interpolate it properly, like that. So what is the condition? What is it gonna do? I know that the numbers might be, I don't know, 1, 2, 5, 5 million, 6 million, whatever the numbers, but what is the condition that he's gonna say if that was true, do it? That's something that we can do on the fly as we call the function. Let's go ahead and do it. I'm gonna say mult function, mult-purpose function, which is here. The numbers, I'm going to give it an array of, let's say, 100, 200, 700, 2, 3, 5. And then the closure is going to say integer in some sort of condition. And I'm going to say, call this integer val, and then say the condition is this, as long as val is below 300. So as you can see, I called a function with an argument, another argument, that other argument of mine is actually a condition itself. So let's run this and see what we get. If we run it below 300, we should get a few of these numbers, 100, 200, 235. But maybe I wanted to decide about a different condition. I wanted to say val larger or equal to 300. Let's see what we get now. We should get only the 700 number. Now, if I were to rewrite this whole thing using nested functions, it would be something like this. And I really suggest you guys don't try this with me. Just have a look at it, because we're not going to really use it. It would be called a nested func, and my nested func would receive these values as input argument. And then it would have a body, which inside its body, it would have another function called internal function. That my internal function receives one value, just like here, it would receive one integer value and would give me back a boolean. And then what does it that one do? That one says, for instance, if val is in this case larger than 300. If it is larger than 300, then return true. All right, so let me write this a little bit. I don't really like typing code like this, but sometimes because I'm trying to zoom into the screen for you guys, I have to. So one is if, that is that, another one is else, and in the else I'm gonna say here return false. So there's an internal function that receives a number, it is larger than something, it returns true, otherwise it returns false. And now within the actual body of function, we would say for each value in vals do this. What should you do? You should say if internal function of each val was true, then do what we did before, print this value. So in here print each val. So this would be the longer way around, if I can show you both of them at the same time. So yes, this would be a longer way around, a nested set of functions, and this would be an easier way around using a closure, that a closure on the fly, whenever I'm calling it, I can actually decide what do I want to see. Also here I have only one condition, but here I could actually decide about the condition as I go through. Like I could have this function and I could have another one, say multi-purpose function, the values are another set of values, and that another set of values, the closure for it says for any value if val is smaller than 500. So the same function is being used at the same time with no changes to the body of the function, which is in here, with no changes to its body, but is doing two different things for us, which obviously is a lot simpler than writing nested functions. So I'm going to remove that nested function, and I'm going to remove that. And now let's move on to another thing about closures, which is called escaping closures. So let's see what is an escaping closure. Escaping closure. Escaping closures are a very particular type of closures that they get called within the arguments of a function, and then they can return back from the function. They are primarily used for asynchronous processes. Asynchronous process is essentially a process where you're reading something off the network and it has to work parallel to your other threads, other, say, user interface thread or computation thread, simply because when you make a connection with a network backend, it might take a little while before you get some results. Let's say it takes half a second or 1 second, or even, if you're on a slow connection, it might take 2 seconds. So in that time, your app shouldn't freeze. So they have to work asynchronously. They have to work parallel to each other. And that's, what we do for situations like that. We use a closure that waits for something and then gets essentially popped back. So with that in mind, let's see how we are going to write an escaping closure. I'm going to go in here and I'm going to assume we have a function that is going to read photos from our backend. So I'm going to say function fetch photos. So this is a function that's going to fetch pictures for us from some sort of a backend that we will see in quite a few sections from now, to be honest, but we can see the process of a closure in here. So I'm going to say my fetch photos has a link that is going to be a string that we read and we find it, and then we want to have a closure for it. My closure, I'm going to call it completion, which is a very common naming convention. People call it completion, so it tells them whether it completed or not. And I'm going to say my completion has these things, has a boolean and has a set, an array of a string of the names of the photos that it found, and it doesn't return anything essentially. So I have a completion closure that returns whether it succeeded or not, based on that returns a set of photos or not, and this I have made it optional because it's possible that this boolean is false and we have actually failed in fetching the information, and as a result these strings are nil, there is nothing in them. And then I'm going to go ahead and say, well, this completion is actually escaping. So it's an escaping closure which will be called later on. So similar to the other closures that we had, a closure inside the body of the function, it gets called immediately, but it doesn't get returned immediately. Unlike here, that whatever is happening in the val and the boolean or whatever this statement is, it must be returned right then. An escaping closure essentially waits for it to be completed and then it gets returned. And that's essentially the power of it. So let's see how we're going to use that. So here I'm going to go ahead and say, let's say we have a status. This status is fed from us from the network, a status coming from network. So now that we don't have access to a real network, I'm going to essentially fake that value. I'm going to say let a status, and I want to make a status to be something that is either true or it is false. So I'm going to say, give me an arc for random, and give me an arc for random of 2, which this number is either 1 or 0, simply because a random number below 2 is either 0 or it is 1. And I'm going to say, if a status, it means if this was true, right? If a status, we want to do something, I shouldn't have written it like that, and else we should do something else. So let's see what we have to do. Let me get myself better spaces in here. So in the case of else, that's quite clear. We have to say completion, and we have to say completion false, and we didn't get any images. That's exactly what he's expecting us to tell him. A boolean value and an array of strings, which is optional. And then in case it was true, I'm going to say completion true. Yes, it succeeded, and give us some, fake photos, photo 1 and photo 2. So that's what we have in here. Let me reformat things a little bit again because I need to see everything once again. So now we have both of these statuses happening, and we have our function. Let's go ahead and actually use it. I'm going to go ahead and say fetch photos, and it says give me a link. So I'm going to say fake link. Imagine that was an actual link. And then it says, what do you want to get at the completion? At the completion, I want to get the result, and I want to get photos array, let's call it. Now, here is what we do. We say if res, if result was true, it means after this event happened, that is the very long event that we currently don't have access to. But if that one happened and it was successful and we got back all of these, and if we had a successful result, then use the photos array. Otherwise, tell us that, oh, there was an error. So I'm actually going to write the otherwise as well. Say else, do this. Print error in reading network, or something to that effect. Now, obviously right now I'm faking the values. I can't really be sure what happens, but we could try it. Let me go ahead and comment these guys out as well. So I only have to deal with this one, escaping closures for asynchronous tasks. So if we run this now, depending on whether that number becomes true or false, we either get to see the photos, or we get, like here, error in reading network because something happened, so we couldn't get those results back. So that's about that. Closures, escaping closures. Closures, we use them as a way of passing functions as an argument into another function to avoid having nested functions. Something I personally do, and you don't really have to do it, but I really like it, is I don't put my closures within the body of the argument. I actually write them as a separate thing. So I essentially say type alias, and the type alias that I want, I'm going to call it in this case, online closure or anything that you want to call it. And that becomes the entire declaration of my closure. So it says online closure is that, so on and so forth. And then in my function, I have a link of the type string, and I have a completion of the type online closure, which is also escaping. Let me format that a little bit so it's easier to see. So essentially, I managed to put my online closure inside a separate variable. Like I said, you wouldn't see this as a very common practice. I really like it like this way, simply because I end up using the same closure in so many different places. I might be dealing with uploading, I don't know, photos, downloading photos, or a lot of times your closure is just a boolean that says whether something completed or not. So I know that I'm using that one closure everywhere, and if I want to modify it, I only modify it once. So that's about that. We looked at different types of closures, simple closures, just how they correlate to a function. We looked at how to write a function that receives multiple different, conditions as a closure as one of its arguments, and each time it can give us a different result. And finally, we looked at escaping closures. And that's about that. With that in mind, let's move on to our next lesson.